Hi all, welcome to Battery Talk, and today we're going to be talking about graphite. Now, I don't know if you saw it in the news recently, but China has just announced that it's going to be requiring special permits for specific grades of graphite, and specifically battery grade graphite.
Yeah, and so this is a whole can of worms, and there's a lot behind this. A lot of political related pieces, a lot of saber rattling from China. But overall, this could be the biggest battery news of the year so far, and have the biggest repercussions going forward into 2024 if we're no longer able to get the graphite we need anywhere but China.
Yeah, and this kind of came out under the radar, right, Aubert? Like, this came out, I think, in Reuters originally, and then a few others picked it up. Um, and then now it's being slightly talked about in the news, but it's got a huge impact that I don't think the general populace requires. So, kind of the problem here, guys, is every conventional lithium ion battery, be that NMC, NCA, LMO, LCO, they all require graphite as their anode, and they all specifically use what's called natural graphite, and 90% of that comes from China.
Yeah, and also most of the synthetic graphite, which is typically the higher grade stuff as well. So all of the new enabling batteries also need graphite, and it's specifically Chinese graphite. As you can see here, it's a pretty dark picture where a lot of the graphite is mined in China, a lot of the graphite is refined in China, including 70% of the synthetic. And then they're also currently making most of the cells, which everybody knows. But basically, graphite's about a third of each battery in terms of its total material composition. And so losing access to that is pretty critical. It means there's no anode if you don't have graphite.
That or it's going to mean a more expensive anode. But it's a big blow nonetheless, because the reason other countries really haven't brought up graphite production is it's dirty. They're literally digging and mining, which is something everybody does, but then it's the chemical refining afterwards to reduce all the impurities and the metals and whatever is in that, ore that they mine out of the system. And nobody wants to deal with that because it's a dirty process.
And it's
So,
very, very energy intensive as well, which has its own problems and its own pollutants.
no, 100%, but, not to dwell on the issues here. The real question I think everybody wants to know is can we recover from this? So I
Yeah,
think, if you look at it, China's 90%, it's about 820,000 metric tons a year of graphite production, and the next biggest player is Mozambique at 30,000 metric tons.
you missed Brazil at 70, but close.
Yeah, yeah. But
But the overwhelming majority does come from China, and while there are a number of other players, the amounts that they're mining are just very small compared to what is actually needed for batteries. Um, and so, which of these players will be able to maybe step it up, but also can the U.S. and the other people that are actually qualified for the IRA materials for batteries step it up?
yeah, that's going to bring a lot of questions about one. I think as far as the IRA is concerned, graphite is graphite, right? Whether that be natural or synthetic, and kind of to bring you guys into a little bit of knowledge, the key differences between natural and synthetic is one is just hard mined from the earth, and the other is made from petroleum coke. The results of that is the synthetic stuff just tends to be higher performing, but it also comes at a significantly higher cost, uh, roughly 20 to 30% more per metric ton. So, you're paying 20 to 30% more per metric ton, which a lot of people avoid, right? We're in an age where EVs are costing north of $40,000 to $60,000, which is not accessible to a large amount of the American and international market. And as we have a kind of a dynamic here, whereas we try to bring LFP online, the thing that LFP's whole selling point is cheaper, sustainable, can be made locally as a domestic supply chain. And the big thing about it, the cheaper part, is now you're making the thing that goes with it more expensive.
Yeah, and the U.S. really has no graphite industry to speak of when it comes to battery grade. There's a couple exceptions to that, and so the U.S. DOE IRA did fund one company, which is a Novion, which is doing basically synthetic graphite. And so they funded them 117 million to build out a plant, but that's going to be a couple of years away from actually moving the needle on supplying anybody. So right now, the other options locally in the U.S. are basically Superior Graphite, who is building a plant where there'll be about 24,000 tons of production in 2026, and then also Nouveau Monde from Canada, which has a couple different projects that they're doing. But those are really the only sort of local supplies of graphite that people are going to have access to. And again, it's in the 20, 30,000 ton a year range, not the 800.
Yeah, and I mean also to
grain.
clarify it, right? Like by 2035, if you believe in the CAGR of Bloomberg and Benchmark Minerals and McKinsey and all those vesting sources, you need north of 7 million metric tons of graphite to meet the 2035 supply chain demand. And like credit, I like that Superior's building a factory. Nouveau Monde is building a factory, but 24,000 tons of graphite is gonna be like a pebble of sand hitting the sidewall of a big problem. And let's also be clear, graphite synthesis and synthetic, it's a really dirty process. So when you're trying to go green, this is kind of the one thing nobody talks about. When you're trying to go green, unfortunately, a lot of these battery products have a lot of nasty chemicals in them.
So that moves us to the consensus. Pretty much, the U.S. wants a domestic battery industry and the localized supply chain to support it, and we've all seen the efforts in that in the last couple of years with all the funding and IRA and other activity. But going back to China, China wants to maintain its battery dominance, and this is a pretty clear play where it's leveraging its graphite monopoly in order to do so.
Yeah, I mean, so without graphite from China, let's be clear. So short term, I think best case, permits are granted to gigafactories operating outside of China, and there will be minimal disruption in the supply chain. Now, granted, there's going to be some very, what I would say, uncomfortable conversations as automotive OEMs outside of China and also the cell makers outside of China have to go to the Chinese government and beg to get the permits to get the graphite so they can maintain their gigafactory production. The probability is we'll see gigafactories paying more for their graphite. I think that's really what's going to happen. Is the cost of batteries are going to go up for batteries made specifically outside of China. And this goes back to Aubert's point, right? China wants battery dominance. They want to basically own the market, right? They want to be selling the end product. They don't want to just be supplying the materials for the end product. And then worst case is gigafactories can't get enough, and everybody's planned gigafactories, all the 35 and 20 and 10 and 5 watt hours for all these like LFP based materials or NCA or NMC, they kind of get stalled. There's nothing there for them to work with for their anode, and unfortunately the contracts for what supply of graphite is available is completely dried up.
Mm-hmm. And what you'll probably see is you'll see it from a tiered system in terms of, higher quality to lower quality and sort of more enabling versus less chemistries where, when cost is not an issue and the supply chain is not an issue, you'll see a lot more LFP. And I think, unfortunately, as a lower cost alternative, effectively, I think those are going to suffer the most when their matching graphite goes up in cost proportionally to the NMC. The NMC performance, I think, can take the price hit a little bit more. And also, in general, it typically uses synthetic or artificial for higher performance anyway, whereas LFP typically uses natural because it's cheaper. So I think that's where we're going to see kind of the biggest pinch is any LFP production in the U.S.
Yeah, I mean, I think what are your thoughts on silicon? I mean, this has been a market or a battery technology that honestly is expensive. It's honestly been partially adopted in very small amounts in current batteries today, but has never gained the traction it was heralded to. So, what are your thoughts on that?
Yeah, I think this is actually a huge bonus for all the silicon companies, and we've covered a bunch of those in previous videos, Group 14, Silinano, and others. Really, the technology issues aside and the swelling aside, which are issues, cost has been one of the other biggest drivers of why silicon is not more widely adopted, right? You're replacing an anode made of graphite with something thinner and maybe better in some ways if you can solve the swelling, but that costs more compared to the graphite. And so this to me really, I think, just makes the silicon look better as a comparison, and especially when you're bleeding it into something that's already majority graphite at 3, 6, 9, 12, 25%. I think it makes the math on that look a lot better when the graphite you're blending it with is a lot more expensive.
100%. And I think, as far as LFP is concerned, LFP and pure silicon will never be a thing, but I think there will be a pretty big effort of how much silicon can you get away with for LFP to kind of help bring the performance up to justify the cost increase they'd see from the graphite, right? And you'd be seeing that slightly on the gravimetric and the volumetric side. But that's kind of it for us today, guys. As always, like, comment, subscribe, and also, if you don't mind, we do this in our free time, and we've set up a Patreon account, so if you're feeling generous, feel free to buy us lunch, a coffee, or just kind of donate anything and help support the channel. Thank you all.
All right. Bye.